All right, you guys, welcome to today's math lesson. Today we are working on the Engage lesson. It is Module 4, Lesson 14. The objective is to multiply unit fractions by non-unit fractions. So the directions tell us to solve and then draw a rectangular fraction model to explain your thinking. So again, on your slides, you may or may not be able to draw these out in order to show me, but again, if you could please practice on your paper or whatever you're writing on at home. And then if you want to take a picture of it, that would be great. You can upload it to our slide or just email it to me or send it to me. Or not. I'll leave that up to you. Okay, but again, you should really be practicing to draw out the rectangular fraction model to explain your thinking. Okay, so we're going to start off with question 1A. 1A, they will give you 1/2 of 2/3. Okay, so this is our unit fraction. So again, whenever we have a numerator of 1, that means it's a unit fraction. So again, our objective today is to multiply a unit fraction by a non-unit fraction. So notice the 2 numerator, because it's a 2 and not a 1, this is a non-unit fraction. This is a unit fraction. This is not a unit fraction because a unit fraction is when 1 is the numerator. Okay, so they're going to give you something that looks like 1/2 of 2/3 equals 1/2 of blank thirds equals blank thirds. And they will want you to fill in those blanks. So 1/2 of 2/3 is 1/2 of blank thirds. How many thirds? Listen again. 1/2 of 2/3, 1/2 of thirds. How many thirds? So you just put a 2 right there. That's the whole number. And so if I have 1/2 of 2/3, that just means, what is 1/2? What does of mean in math? Multiply 1/2 of 2/3. So now just solve. What is 1/2 of 2/3? Okay, well, if I multiply straight across, 1 times 2 is 2. 2 times 3 is 6. Well, that's a sixth, not a third. So what they will have you do is they'll stop you right here. And they're going to say between this 2 and this 2. So on Zern, you guys have seen it written like this. 1 times 2 all over 3. Okay. Whoops. Let me try that again. 1/2 times 2/3. So you can see right here, these two numbers. And on Zern, they would ask you, what's the greatest common factor that you can divide out? So what is the greatest common factor there? What number does 2 and 2 both love? Well, start here. Does 2 love 2? Does 2 also love this 2? Yep. So you would say you could divide out a 2. Divide out a 2. So 2 divided by 2 leaves us with, this would be a 1. 2 divided by 2 here leaves us with a 1. So now when you multiply across, 1 times 1 is 1, and 1 times 3 equals 3. Now we know that 2/6 is exactly the same as 2/3. They are equivalent fractions. So now over here, 1/2 of 2/3, what does 1/2 of 2/3 really equal? 2/6, or in the simplified version, 1/3. So you'd put a 1 there. 1/3. No S. Okay. All right. So is 1/2 more than 1 or less than 1? Should be less, right? 2/3, is 2/3 more than 1 or less than 1? Again, less than 1. So class, what happens when you multiply a fraction less than 1 by another fraction less than 1? What happens to the product? It is smaller or less than both factors. So is 1/3 less than both of these factors? Okay, very good. All right, let's look at question 1B. Okay, question 1B. It will be 1/2 of 4/3. And again, they'll just have you fill in those blanks with the words written out thirds here. Okay, but I'm going to just model the rectangle model on this one. Okay, so I have 1/2 and I have 4/3. What do you know about 4/3? Less than 1? More than 1? Okay, so even though it's more than 1, it is still a non-unit fraction, right? So I'm going to take this and I'm going to show the model of thirds first of all. I need to show 4/3. Well, if I were to shade this in, I would have 1/3, 2/3, 3/3. Now what do? I don't have enough, so I would draw another group of thirds. And I would shade in how many of those? One more. Okay, so now look at it. Do we have right here to here 4/3? So everybody see, do we have 4/3 there? Okay. All right, so if this is our 4/3 right here, they now want me to take half of it. So take half of your 4/3. So I'm going to chop my 4/3. Here's a third, here's a third, here's a third, here's a third. Take all those 4/3 and chop them in half. And shade that in. Oops, I'll pull out my other color now. So I'm going the other direction. And I'll go all the way through and I'll show that that would go all the way through here. Okay, and I will label this as my 1/2. So I just took half of those 4/3, right? So now if I go on solving this, do you see the equation 1/2 times 4/3? So you can just multiply it out because of means multiply. So 1 times 4 is 4. 2 times 3 is 6. 4/6 would be a good answer. Okay. When I look at the model and I see what's been overlapped with two colors, I see black and blue, black and blue, black and blue, black and blue, or the cross hatching on it, both directions. So this is where my answer lies, right here. In class, remember, I'd always have you guys mark those answers solid. So I have 1, 2, 3, 4. Now, if you look at what's been shaded in, do I have 1, 2, 3, 4? Whoops, 1, 2, 3, 4, 5, 6. So if I'm just looking at this first piece of my model, of the rectangle model, there's 6 total pieces. And I have 1, 2, 3, 4 out of the 6 shaded in. Okay? Now, if I wanted to simplify that down, could I simplify it? Yep. What number loves 4 and what number loves 6? So what can be divided out? What's the greatest common factor? You could divide by a 2 and divide by that same 2, because whenever you multiply or divide by one whole, you get an equivalent fraction. So 4 divided by 2 leaves us with 2, and 6 divided by 2 leaves us with 3. So 2/3 or 4/6, they are equivalent fractions and they are the same answer. But the model will be your non-simplified answer or unsimplified answer. Okay, so that is 1B. Let's just look at one more. Okay, let's do 1C, I guess. 1C is going to ask you to solve 1/3 of 3/5. They actually have the word of there, but I know of means multiply, so I'm going to just plug it in there now. I'm going to draw my rectangular fraction model. Doesn't matter if I show thirds or fifths first. Doesn't really matter. I did my 4/3 first just because it was more than one whole, and so for me it's easier to do it that way. So these are both less than one whole. I'm going to go ahead and do my fifths. 1, 2, 3, 4. I've got my 5 equal parts. How many do I need to shade in? Look at your numerator. How many do we shade in? 3. 1, 2, 3. There's my 3/5. I'm going to label this my 3/5. So I know I've used it, right? Okay, now I take that 3/5 and I'm going to chop it up into how many equal parts? 3 equal parts. So take the 1, 2, and on Zern, they'll have you go all the way across with that to show the full units. And I need to shade in how many of the thirds? Just one of them. So you can use a different color or not. I'm going to just make my lines go the opposite direction. Okay, now you're looking at just what's highlighted, both colors or with both lines. And you can see your answer. Oops, I forgot to label this. This is my 1/3. So I can see my answer lies right here because I see the blue with the black, or my cross-hatching lines going both directions. So I see 1, 2, 3. So my answer should be 3 out of how many total pieces? Let's go ahead and multiply it out and see. 1 times 3 is 3. 3 times 5 is 15. And if I check this out, I'd say there's 1, 2, 3. It's a 3 by 5 array. So 3 times 5 would give me the 15 total squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 total squares. And 3 of them are highlighted or colored in with the 2 colors. Okay, so 3/15 would be a good answer. For those that want to practice simplifying, you would say, what could I divide out of my 3 and 15? So what's the greatest common factor that you can divide out? So start with your smallest number out of the 2. So 3 is smaller, so ask yourself 3. Does 3 love 3? Yes. Does 3 also love 15? Yes. So that means you could divide out a 3. And 3 divided by 3 would leave us with 1. And 15 divided by 3 would leave us with 5. So either answer would be correct. 3/15, which matches up with your model, or the simplified answer of 1/5. Okay, so when you guys turn in your work today, if you would like to, take a picture of all of your drawings to show me you remember how to do the fraction models, and also give me your final answer when you solve the equation. All right. So good luck on Module 4, Lesson 14. Please call me. I'm here if you need any extra help. Okay? See ya. Bye-bye.